So this lecture is going to be about measuring type. And it's going to go a little bit deeper than that because I want to show you some of the tools that we used to use as graphic designers and now some people still use, which include the proportional scale. And this thing, you would just turn the measurement of where you are by where you wanted to be, and it would tell you what the percentage is that needs to be increased. Or if you knew that you had a certain size and you needed it to be blown up 300%, it would tell you how big that was going to be. And that's what a proportional scale was for. And they're still in use today by crafters and quilters, and many designers still use it to help them figure out what the scale needs to be when using a photocopier. Then we also had the centering ruler. The centering ruler was used to center things, just like it says, where there would be 0 in the middle, and then it would go out to 6 to 8 inches on each side. Sometimes they also had metric, and sometimes they also had grids, which were helpful in making sure that it was straight. Then we also had something called a pica rule, or a pica ruler, and that has a little bit more to do with what we're going to be talking about today. And it just measured picas, and if you ever end up in the newspaper or magazine industry, you might end up getting a hold of one of these. Then the last one I'd like to talk about is the leading rule. The leading rules, generally the better ones, were clear, and it would allow you to determine what weight a line was that had been printed and give you a ballpark idea of the size of font used and the leading used, rather than trying to calculate it all out. Now, these are all older tools of the trade, dating back, I think the last time many of them were in use were sometime in the 90s. But it gives you an idea of how we used to operate, and some of those things are still quite functional today. So we'll go ahead and get into today's deeper lecture on how you measure type. There are 3 basic type measurements with which the designer must be familiar. We have points, we have picas, and we have units. The first 2 apply to all typesetting methods, while the third, units, applies only to phototype setting. So hopefully you will never ever have to deal with that. So points are used to measure the type size or point size, while picas are used to measure the line length or measure. There are 12 points in 1 pica and 6 picas in 1 inch. The type that, if you happen to be looking at the lecture notes, it's 12-point type. Oh, it's 11-point Baskerville set in 20 pica. Now, looking at the slide, you can see just how small a point is and how it relates to both pica and inches. Measuring type. In order to understand how points are used to measure type, let's examine a piece of type. It is a rectangular block of metal with a printing surface on top. The block itself is called a body, and the printing surface is called the face. The height of the body is 0.918 inches and is known as the type height. Although this dimension is not important to the designer, it is very important to the printer that all design type be exactly the same height in order to print evenly and consistently. The width, which is called the set width or set, is dictated by the width of the individual letter, the M and the W being the widest and I being the narrowest. The length of the body is the dimension of greatest concern to the designer. It is known as the body size. And it is known as the body size, and it is this dimension, measured in points, that determines the size of type. For example, a 10-point body produces 10-point type. An 11-point body produces 11-point type. When measuring type, Although the difference of a single point may seem insignificant in smaller type sizes, it can be very noticeable. So type sizes. Metal type comes in many sizes ranging from approximately 5 point to 72 points. Type sizes fall into two categories, text type and display type. Generally, text sizes are 14 point and smaller, while display faces are 14 points and larger. It is important to realize that type sizes refer only to the body size and not to the size of the printed letter. You're looking at a slide that should be kind of showing you the three pieces of type along with the three printed letters they produced. The body size of the metal type measures 60 points, while the printed letters vary in size. Since no individual letter fills the entire body, you can see why measuring the printed letter will not give you the point size. Since most designers do not work with metal type, the only way to confirm a type size is to look at a type specimen book, usually supplied by the typesetter or wherever you happen to have gotten your metal type. X height. So before we have learned that the X height is the height of the lowercase letter exclusive of ascenders and descenders. Although the X height is not a unit of measurement, it is significant because it is the X height, not the point size, that conveys the visual impression of the size of the letter. Typefaces of the same point size may appear larger or smaller because of the variations in this X height. To illustrate this point, 5 type specimens were produced for the slide. Although they are all 60-point type, they appear to be different sizes. This is because some have a small X height, such as Bodoni, while others have a large X height, such as Century Expanded and Helvetica. This size difference may seem insignificant when considering a single letter, but in blocks of type it is very noticeable. Look again at the slide where the same 5 typefaces have been set in blocks of 10-point type. Notice how the Garamond with its small X height appears so much smaller than the Century Expanded or Helvetica with their X heights. Also notice that although they are all 10-point type, they do not set to the same number of characters per line. Letter spacing and points. With metal type, letter spacing, which means adding space between letters, is accomplished mechanically by inserting pieces of metal between the type. The spacing metal, being lower than the type itself, does not come in contact with the paper and therefore it will not print. Most fonts have spaces of 1 point, which were made of brass, which can be used singly or in groups. Other spaces are even thinner. A half point, also copper, is copper, and a quarter point, which was often stainless steel because that was the only metal strong enough. There are even letter spaces made of paper. This should give you an indication of just how finely letter spacing can be adjusted. There is little occasion for letter spacing in metal type except when setting type in all caps. Word spacing and points. Word spacing in metal type, like letter spacing, is accomplished mechanically by inserting pieces of metal which are lower than the type between the words. These pieces of metal, called quads, are all related in size to the M quad, which is the square of a type size. For example, if the type is 10 point, the M quad is a square 10 points by 10 points. If the type is 72 point, the M quad is 72 points square. Since 1 M would be too much space between words, smaller pieces of metal, which are subdivisions of the M quad, are used. They are 2 to the mth, which is an N, 3 to the M, which is thick, 4 to the M, which is middle. 5 to the M, which is 1/5 of an M, is thin. 6 to the M, which is 1/6 of an M, is hair. Okay? So the slide shows the M with its subdivisions and how they affect a line of type when they are used as word spacing, leading, and line spacing. In addition to the space between the letters and words, it is also possible to vary the space between lines of type. To accomplish this, metal strips of varying thickness are placed between the lines of type. This is called leading. The metal strips, or leads, are measured in points. They are less than the type height, and do not print. Their function is merely to separate the lines of type. Also, 4 blocks of 10-point Garamond, you're looking at the slide now, are 4 blocks of 10-point Garamond. The first is set solid, that is with no leading. The next block is set with 1-point leading, which is indicated 10/11, 10 on 11. The first figure indicates the point size of the type. The second indicates the point size plus the leading. Although leading does not print, we have indicated it by printing a black rule of the same thickness between the first 2 lines of type in order to help you visualize this process. It's important to note that adding leads between the lines does not affect the type size or the length of the line. It merely moves the lines farther apart. It does, however, affect the appearance of lines of type. As you can see, the more leading, the more grayer the block of type. Phototype, unlike metal type, does not involve the use of leads. Therefore, the lines of type can be set even closer than solid. This is referred to as minus leading or minus line spacing. Needless to say, there is a limit to how close lines of type can be set before they overlap. So in the computer scheme of things, and in the modern definition of leading, leading is determined as the distance between one baseline and another baseline. So stick that away in your hat somewhere. The measurement leading is defined as the distance between one baseline and the next baseline. In phototype setting, the width of the characters, or the set width, and the space between letters and words are measured in units. The unit, unlike the point and pica, is not a fixed measurement because it is based on the M. The unit varies with each type size. So it's based more on a percentage of whatever that letter form happens to be. During the typesetting process, a counting mechanism, which is part of the machine, controls the length of each line by adding up the unit values of the characters and the spaces between words. One thing to keep in mind when working with units is that they are always relative to the type size. Letter spacing in units. In phototypesetting, letter spacing is measured in units and sometimes half units, but most designers find it more convenient to specify the letter spacing with terms normal, loose, also called open, tight, and very tight. Display type may also be touching. Normal letter spacing, as the name suggests, is the way the type comes off the machine with no space added or deleted. With loose letter spacing, space is added. With tight, very tight, and touching letter space, space is deleted. Letter spacing can be overall or selective. In overall letter spacing, all the letters are affected. In selective letter spacing, more commonly referred to as kerning, only certain letter combinations are affected. Remember that adjusting the letter spacing will affect the number of characters that can be set into a line of type.